We're going to start out with part 1. This is question 2, okay, in the Unit 5 and 6 test. So this would be one. It actually came from a previous unit, but it sort of fits in with this unit, and it was on the test. So we're going to kind of just go over that. So here it wants us to calculate the percent abundance of each isotope, and it's giving us the average atomic mass. So we're going to do that our average is going to equal to our fraction abundance, which we'll just call it X, times the mass, 19.99. And it says there were only 2. So if the fraction abundance of the first one was X, this one is going to be 1 minus X, and then times its abundance, which was 21.99. And so then we would simply do the math to solve that for X. And you should get, let's see, that's this one. So on that, the value that you got from that, and again, you can pause on this if you want to see the math worked out. I just wanted to show you the setup. But so our percent abundances is 90.5 and 9.5. So you should have gotten for one of them, let's see, if you set it up the way that I did with the 19.99 one as X, that means you would have gotten your fraction abundance for the X, you'll get 0.905 and then times 100 to get the percent. And then 1 minus that would be 0.095 to get the other one. All right, the next question was to calculate the number of neon 22 atoms in a 12.55 gram sample of naturally occurring neon. So let's just kind of look at, or well, wait, let me go back. You got 1 point for the correct answer, meaning that you got both percent abundances correct on that. So then in part 2 of that, what we're doing is, since this is grams of the naturally occurring neon, so this is grams of both isotopes. So we're going to use the average mass to convert that into moles. All right, so we're just dividing by the molar mass of neon. Okay, right there. And so that's going to give us our moles of neon. And then from above here, we said that our neon 22, that 9.5% or 0.095 fraction was the neon 22. So that's what this second part here is. So it's taking of all the moles, then 0.095 moles of them would be the neon 22. And then it wanted atoms, so then the last step would be just to convert to atoms. And we'll see on the rubric here, so if you use the correct molar mass, in other words, you divided by the 20.18, that was worth a point. And then you got a point for incorporating that fraction for the neon 22, so that second step right there. And then you got a third point for getting the number of atoms there, taking it all the way to that step. Okay, let's go back. And so then, all right, then we got to question C. And so this is where we got into the electromagnetic radiation calculations on there. And so we're going to jump down to, I should have the key for that right here. Okay, so in here, you can see that we were given a frequency, okay, and it doesn't want to let me right there. And so frequency, that's our Greek letter nu, and it wants us to calculate the wavelength, and our wavelength is the lambda. So the equation on our equation sheet that we had was speed of light is equal to the wavelength times the frequency. And so when we solve for that, let's see, this didn't give us what our intermediate value would be, but it would, if you do the 3 times 10 to the minus 8, let's just see how we did that. So for the correct setup, so, and I think a good number of you actually got this one. So 3, 10 to the 8th, and then divide by 4.34, 10 to the 14th. So that you should have gotten like an intermediate value of 6.9 times 10 to the minus 7th, right? And then if you correctly converted it from meters, that would be meters, into nanometers, then you got your 690 nanometers. So again, 1 point for the correct setup, which correct setup generally got you that value there, although I really was just looking, if I saw this here, well, with the lambda, if you did that part of it, then you got the point. And then 1 point for the final correct answer, which was your 690 nanometers. Okay, and then here we have a molecule of O3 absorbs a photon with a frequency of 1 times 10 to the 15th hertz or per seconds. How much energy does it absorb? So here, energy and frequency, we're going to use this equation right here. And so when you plugged in your numbers, the 6.63 times 10 to the minus 19th is your joules per photon. Then for the second part here, it gave us energy, but it gives us, the key thing here was it was giving us this energy in kilojoules per mole. And then it wanted us to compare that to the energy from part 1. And the unit on part 1 was joules per photon. Oh, I see what's happening. It's like my pen isn't working, but it's because, there, okay. There we go. It's because that's in joules per photon. So we can't compare them until we get one of them in the correct units. So here it's showing that you took the answer from part 1 and then did the conversion to get it into kilojoules per mole. And when you did that, then you were able to make the comparison that the energy from part 1 is greater than the required energy to break the bond, and so therefore the bond can be broken. You got 1 point earned for calculating the energy, and then the other point if you made this correct comparison here. Now, the other way you could have done it, and some of you did it that way, is that if you took and converted let's do it in a different color. So if you converted the 387 kilojoules per mole, and then if you went that way, so then if you did 1 kilojoule to 1,000 joules, and then 1 mole is 6.02 times 10 to the 23rd photons. Okay, so if you did that, and then that would give you, let's see, 387 is 1,000, and divide by 6.02, 10 to the 23rd. Okay, so 6.43 times 10 to the minus 19th. So if you converted that, and then you made the comparison that the 6.63 times 10 to the minus 19th joules was greater than the 6.43 times 10 to the minus 19th joules. So some of you did it that way, which is perfectly fine. You should still get the 2 points if you did it that way. Just the key thing is just remember they have to be in the same unit in order for you to be able to compare them. Okay, so continuing on. The next question related to today's review was question number 4 in part 2, which was a PES question. And so it gave us the PES for nitrogen and for calcium. And it said, circle the peak that contains the first electron that would be removed from a nitrogen atom. So remember, the first electron, that's going to be the easiest one to get, which is going to be the one that's the farthest out. And remember, these are your ionization energies, the energy required to remove the photon. You'll also see these possibly with binding energy, which is going to be the same thing. That's how tightly it's held in the atom, which is the energy that you have to pull against to get it away from it. So here we're looking for the one with the lowest, which the 1.4. So this would represent the electron, the energy of the electron that could be removed first, the outermost. And so let's just take a minute here and let's look at these. So the ones closest are going to have the highest ionization energy. So this would be, that peak is your 1s, this will be your 2s, and this will be your 2p. So that would be your outermost on there. Okay. And then it says how much energy is required to remove this electron, and there the answer was 1.4. And so I think let's double check. On the answer key, it should be out of here. And so our rubric for this was you got 1 point for circling the peak, and then I don't know why that got split. Oh, for some reason that wasn't on there. But the other, this part here, I don't know what happened to that, but that was also worth 1 point for stating the amount of energy that was there. All right, so let's go back up here. So now it says, once the first electron is removed, would you expect the energy required to remove the second electron to be greater than, less than, or equal to the energy required to remove the first electron? Okay, and so here, if we go down to our thing here, all right, and so the answer is that more energy is required to remove the second electron. So that was you had to say that it would take more. And then you could, there were two kind of possible ways you could address this, is that you could talk about the fact that that the positive charge in the nucleus was going to stay the same, but after you remove the first electron, that same amount of pull was now being distributed to fewer electrons. So each remaining electron was now held more tightly than it was before. So that was one of the explanations. And the other one would be that you could also say, kind of, again, based on Coulomb's law, that your radius, when you remove an electron, the radius gets smaller. And so Coulomb's law said the closer it is to, the closer the charges are together, here charges are the electron and the nucleus, then the higher the attractive force is, which means your ionization energy would be higher because it's more energy to remove it. So either one of those explanations would earn you the point. And again, the key thing to do with these, because now we're getting into some of the conceptual ones, is kind of look at the rubric, read it carefully, and then read what you wrote carefully. And again, don't like fill in the blanks with your thoughts and think about, you want to think about, if I, the grader, am reading exactly what you wrote and comparing it to exactly what is in this rubric, you know, that's what I'm looking for. Okay, I can't give you a point based on your intent. So really start studying the language, because that's what this Unit 5 and Unit 6, a lot of those questions were about the language that you used. And was it the proper language to fully communicate your understanding of the question? So again, focus in, really look as objectively as you can. And if you intended, if you read the rubric and you say, that's what I intended, but I still didn't get the point, then look again at what you read. If you still aren't sure, get the person next to you to read what you read and see if they can explain to you why you didn't get the point. If they can explain to you why what you wrote does not completely match up with the rubric. Okay. And then the next one, it said, explain why atoms of phosphorus have a lower first ionization energy value than those of nitrogen. Okay, so if we look at phosphorus and nitrogen, they are right above each other. So that means that their nitrogen has its outer electron in the 2p, and phosphorus has its outer electron in the 3p. And so if we look at that, then we're comparing a difference in the distance. So you should have said something to the effect of, again, based on Coulomb's law. And on this one, did it ask you? Yes, it did ask you to reference Coulomb's law in your explanation. So based on Coulomb's law, Coulomb says as distance increases, the overall attractive force decreases. So our ionization energy would be lower for P than for N. And again, you'll see up here, see how specific it was. And I highly recommend you do that. If you want to be sure to get that point, then don't just say that they're farther away. Say, okay, their phosphorus are in the 3p, its outermost are in the 3p, whereas nitrogens are in the 2p. Be that specific. Don't just say it and assume that I'm going to think, oh, because you said that, then I know that you know that phosphorus outer electrons are 3p and nitrogens are 2p. Okay, be that specific when you're referencing the differences in the outermost electrons. Okay, and that one was worth 1 point on there. Okay, so that's the kind of the explanation for the questions that were on the test. Again, the goal of this part of our review is for you to figure out, if you didn't get all the points, why didn't you? What did you not put down on the paper that you didn't get the points? Okay, now what I have for you in the Google Drive, I'm going to go there hopefully quickly, and Google Drive, and I have created a new folder within AP Chemistry. Maybe it's going to open. Okay, and it is right here. You'll see it in Unit 5 and 6 retests. So if you'll open that, there's a folder for today's session. All right, this is EMR Bohr PES, Wednesday, March the 8th. In there, I have 3 documents that are these AP Chapter 7 Calc Practice 1, AP Chapter 7 Calc Practice 2, and PES Practice Problems. The other 2 are the keys for the Chapter 7 Calc Practice documents, and then the answers for the PES Practice Problems are on the last page of that document. And so I'm going to go back to the notebook and just kind of just show you what they are. So the Calc Practice 1, these are the electromagnetic radiation. So this is practice with these formulas here, okay? So that's practice problems for those. And then the Calc Practice 2, those are Bohr model practice questions. So this is using the Bohr equation. And even though we didn't necessarily use it in the on the test, It is still fair. I mean, this is the review for that, so it's fair to be able to ask you questions about that. Um, in here, they have a couple that use the de Broglie wavelength, and so we're gonna like just knock out 5 and 6. Okay, you don't have to worry about those. But so there's 4 practice problems, and again, the answer keys are there in separate documents. Then you also have the PES practice, and those are just some conceptual, but these are multiple choice questions on PES. Okay, and these actually came from the College Board website. And again, the answers are at the bottom. Okay, so take a look at these. If there are any of them that you're not clear on why the answer that's in the key is the correct answer, if you would just post the question up on Google Plus, and I will respond to your question and explain you, maybe do a little video on that particular question. Okay, so good luck with the practice on this. And if you need additional practice, the PES, if you just Google AP Chemistry PES questions, there's a lot of stuff that will pop up. I do also have some study guides that go with the Zumdahl textbook that you can sign out, and it has like for chapter 7, it has again some practice problems with answers in there if you feel like that you need some more practice with that. And when I'm back on Thursday, I'll make those available for people to sign out if you need to. Some of you have already been working with me and already have one of these, but if you feel like that would be a good resource for you, then you are welcome to sign one of those out.